Hello, everybody. Hello, and welcome to all our viewers worldwide that today gathered to listen to our webcast, latest developments in electric vehicles battery packs, powered by YOL Group. I am Faisal El-Kamasi, Senior Global Sales Support Manager for YOL Group, and I will guide you during this webcast. This webcast will discuss some of the most promising technology for lithium-ion battery packs, cover the latest market trends, technology trends, forecasts, and describe the supply chain related to lithium-ion battery pack and its components. So I would like to welcome our speaker, Dr. Shalu Arwal, Power Electronics and Material Analyst at YOL Intelligence, part of YOL Group. Before we get started, I remind you that you are encouraged to submit questions to our speaker during all the live events using the Q&A box at the left bottom of the screen. Question will be answered right after the presentation with a Q&A session of about 10 minutes. In case we don't have time to answer all of them, we will follow up with you by email. To conclude, this live event is recorded. You will receive tomorrow an email with the link to access the recorded session. Now, let's start the webcast. Shalu, the floor is yours.
Thanks, Faisal. So, hello everyone. Thank you for joining us. My name is Dr. Shalu Agrawal, and in this webcast, I'm going to discuss with you about the latest development in electric vehicle battery packs. So, in this webcast, we will discuss about the technology trends of battery packs of electric vehicles. We will discuss about the various components of battery packs used in electric vehicles. Then we will discuss about the forecast as well as supply chain. So, let's go. So as we know that batteries is everywhere, no? Starting from consumer goods like our laptop, mobiles, tablet, to power tools, no? We have wireless power tools. Then we go to higher voltage applications like stationary storage application, automotive industries. We can find batteries everywhere. But then if you see that all the applications, they have their typical voltage range and energy capacity requirement. So to fulfill those voltage requirement and energy capacity requirements, number of cells need to be assembled together to reach or to fulfill this requirement. For example, if you have a small consumer good like a mobile phone, the voltage range is around 3.7 volt. In that case, only one cell would be enough. But when we move from low voltage application to high voltage application, a number of cells need to be increased. So here we can see a few examples, like if we have applications like our tablet or a laptop, in that case, the typical voltage range is around 10 volt or 11 volt. In that case, only 5 to 6 cells need to be assembled together to fulfill the requirement or to reach up to this voltage range. But when we move from these low voltage applications to high voltage applications like automotive industry, the typical voltage range for automotive industry is 400 volt. So in that case, to reach up to this 400 volt, a lot of hundreds or thousands cells need to be assembled together. So this is a typical way to assemble a lot of cells and to fulfill that requirement of high voltage applications. So like, let's say we have a lot of number of cells, then a few number of cells are assembled together to make battery modules. And the number of modules are again assembled together to make the final system. This final system, which consists of number of cells, is called battery packs. So actually, a battery pack is composed of number of cells, but apart from cells, there are many other components also. So you can see from left-hand side, the key component of any battery pack is cell. But then in this battery pack, there are thousands of cells. So to manage those cells, like for protection of those cells, to control those cells, battery management system is required. So another component of battery pack would be battery management system. Then as we know that lithium ion batteries are very sensitive to temperature. So to keep those cells into optimum temperature range, thermal management system is requirement. And next is safety components. And safety component is very important, especially for automotive industry. So various kind of safety components are also there in a battery pack. And then is electrical interconnections, and there will be a lot of number of cells, and these cells need to be electrically interconnected. So this another component of battery pack would be electrical interconnection. And last but not the least is housing. So housing is like a box where all these components, including cell, BTMS, thermal management system, will assemble together. The right-hand side picture, you can see this is a typical battery pack structure. Here you can see maybe in this structure, left-hand side is battery management system. Below side, you can see the cooling plates. Left-hand side, you can see bottom cover. Bottom cover is like housing. And then we can see battery modules also. Okay, so now we are good with the battery pack. We know the definition of battery pack and what type of components are there in a typical battery pack. But from now, we will just focus on electric vehicle battery packs. Yeah. So first, let's discuss how to design these battery packs for electric vehicles. Or in other way, we can say that how to install a lot of cells into an electric vehicle. So actually, there are three ways to make battery packs for electric vehicle. First approach, we can say modular approach. This is the most common approach actually. So in that case, we have also seen in previous slide that number of cells like assembled together to make a battery modules. And then in next step, number of modules are again assembled together to make a battery pack. So you can see the first picture, there is cell to module and then module to pack. This approach is the most common approach, and today most of the car makers are using this approach. This modular approach, actually, it's very flexible. Let's say that we have a lot of we have the battery modules. So the same battery module can be installed in different cars, so different electric vehicles, depend on the voltage requirement. The next approach to install cells into vehicle is cell to pack approach. This is a new technology, and right now a few car makers are already started working on this technology, and few car makers like BYD, they already started using this cell to pack approach in their electric vehicle. In cell to pack approach, actually the cells are directly assembled and put inside the battery pack. So to cell to module step will be completely eliminated. So the cell will be directly put in the battery packs, and that battery pack will be directly installed in electric vehicles. Right now, BYD, Tesla, and a few more companies, car makers are working on this technology in this cell to pack approach. And the last one, the newest one, is cell to sachet approach. In cell to sachet approach, actually cell to module step or cell to pack, both steps will be completely eliminated, and the cell will be directly installed into the electric vehicle sachet. Right now, this only a few car makers like BYD, Tesla are working on this approach. Here is a few examples of modular approach. As we know that this modular approach is the most commonly used approach, and most of the car makers are using this modular approach to install cells into the electric vehicles. So here, top side, you can see a Tesla car battery pack. Right, left hand side, you can see a clear picture of battery pack having a lot of battery modules. And then right hand side picture, you can top right hand side, you can see a single battery module of Tesla battery pack. From this right hand side picture, we can see that Tesla is using cylindrical cell, and which is clearly seen in this picture. And then if you see right hand side top picture, you can see a green PCB type board, which is the battery management board. Below side, left hand side, you can see the battery pack modular approach from Ford. So Ford is going to use this kind of modular approach in their electric vehicle. Then Hyundai is also, they have modular approach. And as we know that General Motors and LG Energy Solution, they are together, they have a joint venture, and they are also making lithium batteries using this modular approach. So these are a few examples, but there are many more car makers using this modular approach. This is the example of cell-to-pack approach by BYD. So BYD is a Chinese company. It's a car maker as well as cell maker. So BYD, if you see that left-hand side, BYD, they have some specific cells. They call it blade cells. These blade cells is unusually long than the conventional cells. And to install these cells into the electric vehicle, they are using that cell-to-pack approach. So you can see the right-hand side, below side, BYD cell-to-pack approach. If you compare this cell-to-pack approach with the cell-to-modular approach, that upper side, then you can clearly see that in cell-to-pack approach, there is high space utilization. Meaning if the battery pack size is same in case of cell-to-pack approach or cell-to-module approach, in cell-to-pack approach, more number of cells can be installed. Yeah. So in that case, this for same size of pack, energy density can be increased. Third is the example of cell-to-sachet approach by Tesla. So Tesla called it structural battery pack. For structural battery pack, Tesla, they are going to use their cylindrical cell, bigger size cylindrical cell, that 46, 80 tablet cells. And then below side, you can see that this cylindrical cell, 46, 80 size cylindrical cell, Tesla is going to use, Tesla is going to install these cells directly into the vehicle sachet. Now we know that what about battery packs and the various way to design battery packs for electric vehicle. In this chapter, we will discuss about the various pack components, and as well as we will discuss about their technology trend. The most important component or the key component of any battery pack is batteries. In electric vehicles, there is lithium-ion batteries are used. And lithium-ion batteries also based on their cathode chemistry. There are various kind of lithium-ion batteries like lithium cobalt oxide, LCO. Then we have NCM batteries, which have lithium, nickel, cobalt, manganese oxide in cathode side. Then LMO, LFP, yeah, lithium iron phosphate, NCA, and so on. Today, if you see that more and more car actually manufacturers, they are focusing on to increase the driving range. So for that, they are focusing on to increase the specific energy density of battery pack. From this graph, you can see the energy density of different type of lithium-ion batteries. Among these lithium-ion batteries, actually the most commonly used cathode chemistry is NCM. So most of the car makers use this NCM type of lithium-ion batteries in their electric vehicles. NCA chemistry is used by Tesla only. And now the second most used lithium-ion battery chemistry is LFP. Here is the electric vehicle cells technology trend. So in previous slide, we see that because NCM has a high energy density, so most of the car makers are using these NCM cells. In the past, a typical NCM cell was used. Typical NCM cell, meaning the formula of NCM was NCM 111, meaning that in NCM there is equal ratio of nickel, cobalt, and manganese. Yeah? Although the high energy density of this typical NCM cell were high, but you see that there is equal ratio of cobalt, nickel, and manganese. So there was very high content of cobalt. And we know that cobalt is associated with some concern, right? Actually, the one is expensive. So actually, cobalt is the most expensive material of the cell. And secondly, cobalt is also associated with some geopolitical issues, like most of the cobalt mines are in Democratic Republic of Congo. So there may be some geopolitical issues, then ethical issues like child labors. So that's why the car makers are, moving towards low cobalt and high rich cells to increase the performance of the cell. So now most of the car makers, they have these low cobalt and high nickel rich cells in their electric cars to increase the performance of the cells. For example, BYD, Hyundai, Kia, BMW, Hyundai, Kia, Daimler, many more car makers are using this NCM battery with low cobalt. Low cobalt chemistry would be the one example would be NCM 811. 811 meaning there is 80% nickel and 10% cobalt and manganese. So there is so in this NCM there is only 10% of cobalt, and there is another new chemistry with low cobalt and high rich cobalt, cathode side is NCMA. In NCMA actually there is 5% cobalt and more than 80% of nickel. Right now, Tesla, they are planning to use this NCMA based chemistry in their upcoming electric vehicle, as well as GM and LG together. They have a joint venture for making Ultium batteries. In Ultium batteries also, they will use this NCMA chemistry. The next trend is moving towards the affordable cells. So right now, like for car makers, it is very important to reduce the cost of the cars to make them more affordable. So in that case, the more and more car makers are now moving towards this LFP cells. LFP cells here you can see there is no cobalt and nickel. So the cost of this LFP cell is much lower than cobalt-based cells. Many car makers are already started using these LFP cells in their electric vehicles like Tesla, the Chinese company BYD, and many car makers are planning to use these LFP cells in their upcoming electric vehicle like Hyundai, BMW, and so on. Next technical trend for battery cells for electric vehicle would be cell size, design, and format. So like now we know that most of the car makers are planning to increase their energy capacity. For that, all the car makers or battery cell manufacturers, they have different ways to increase their energy capacity. So one of the examples would be increasing, one of the way would be increasing cell size. So if there will be, the cell size will be increased, in that case, energy capacity per cell would also increase, yeah. So in that case, if there will be energy capacity per cell would be increased, in that case, the total manufacturing cost dollar per watt hour will also reduce. So now, right now, Tesla, they are making that bigger side of cylindrical cells, like 4680, which is much bigger than the previously used cylindrical cells. BYD, they also have a blade battery, which is much longer than conventionally used cells. The second way is like optimization of format. So different car makers and battery manufacturers, they use different formats. Like Tesla, they use cylindrical cells. Pouch cells are mainly used by Korean players like LG Energy Solutions, Samsung SDI. They mainly use this pouch format. And then there is a prismatic format, and most of the European players, they use this prismatic format. The third way to improve the quality of batteries or battery pack would be optimization of form factors. So different players, they have different way to increase the properties. Like BYD, they have blade batteries. Then another way to increase the size of the pouch cells. So if there will be longer pouch cells, then again energy density per cell would be increased. Or to increase the energy capacity, it would be better to move from modular approach to cell-to-pack approach. In that case, we have seen in previous slides that if there will be cell-to-pack approach, then more cells can be accommodated in the same size of battery packs. So different car makers and cell makers, they have different ways to improve their cells. So this is about the most important component of battery pack was cells. And now the second very important component of any battery pack is battery management system. So battery management system, actually we can say that it's a brain behind a battery pack. This battery management system, it's monitor, control, and protect the battery pack. So the main functions of BMS is actually to check the health of cells, to check the charging status of the cells, to protect the batteries, like protection from overcurrent, protection from over and lower voltage, under voltage, protection from over and under temperature. Then cell balancing, to check that if all the cells are equally charged. And then if battery management system can manage all these things. In that case, the lifetime of battery can be improved, capacity can be improved, and working condition will also be improved. So that battery management system is one of the most important component of any battery pack. They are actually in BMS, we have various kind of topology, but for low voltage application, there is different topology, but here we are talking about electric vehicles. So for electric vehicles, the most commonly used BMS topology is master-slave. Here, left-hand side, you can see master-slave, meaning that BMS has two units. The central one, you can see the M is master unit, and then it has many slave units. Yeah, so this one slave unit can be connected with number of cells or maybe a module of a battery pack. And then these all slaves can connect it with the master unit of BMS to monitor the health of batteries of this battery pack. Right-hand side structure, you can see the Tesla module, and then here the green side is BMS board. I look like a PCB board. And the next very important component of battery management, battery pack is the thermal management system. As we know that lithium-ion battery are very sensitive towards temperature. And now if you want to get the maximum performance of cells, lithium-ion battery cells, then these lithium-ion battery cells should be in their optimum temperature range. For lithium-ion batteries, the optimum temperature range is around 20 degrees centigrade to 30-35 degrees centigrade. But when we know that when battery packs start working, then cells started releasing some heat. So the releasing heat need to be dissipated smoothly and quickly to reach that, to maintain this optimum temperature range. So in electric vehicle, actually there are two cooling systems to keep this cell into the optimum temperature. One is air cooling and another is liquid cooling. Air cooling is like forced air cooling, like using fans. So in the past, many car makers were using this air cooling system in their electric vehicle, but now many car makers are using liquid cooling. In liquid cooling, actually, there is we have coolant. Coolant is, for example, a mixture of water and glycol, and these coolants are like flow in a system of pipes in the battery pack to maintain the temperature of cells or to cool down the cells quickly. Here is one of the examples of Tesla Model 3. So Tesla Model 3, you can see the liquid cooling, but now many car makers like Hyundai, BMW, they are also using this liquid cooling system in their battery packs. Next important component of battery pack for electric vehicle is electrical interconnection. So now, in the battery pack, there are thousands or hundreds of thousands of cells, and these cells need to be electrical interconnected to each other. So there are many methods actually to connect, to electrically connection of these cells to each other, like ultrasonic bonding, resistant welding, laser welding, and different bonding can be, it actually depends on the various formats. So for cylindrical cells, any kind of bonding is fine, but prismatic cell laser welding is mainstream or most preferred. For pouch cells also, laser welding is mainstream or most preferred. So in electric vehicle battery pack, actually laser welding is the mainstream, but the electrical connection actually depends on the different format of cells. And here is the various safety components, which are the safety, like in battery pack, safety is very important, especially for electrical vehicle battery pack, safety is much more important. So in battery packs for electric vehicle, we have various kind of safety components like protection from overcurrent, protection from temperature, high temperature, low temperature, protection from high voltage. So in generally, there are various kind of safety components are used, like fuses, DC breaker, contactor, all these and many more. And all these safety components, they have their own advantages and disadvantages. And here is the battery pack housing trend. So housing is like the box where all these components, including cells, battery management system, thermal management system, are assembled together. The most commonly used materials for pack housing is aluminum, plastic, steel, and now it's composites like carbon fibers, glass fibers. And actually type of housing actually depends on the way how we make this battery pack. For example, for cell to module approach, we have actually battery pack as well as modules. So we have two label of housing, pack housing and module housing. When we go from cell to module approach to cell to pack approach, there are no modules, but just battery pack. So there will be one label of housing, only pack housing. And the last one, you can see the cell to sachet approach. So actually in cell to sachet approach, there is no module or there is no as such pack. So in this cell to sachet approach, there will be no as such dedicated housing. For cell to sachet approach, vehicle sachet would be used as a housing for battery pack. So it was about the various components and their technology trend used in electric vehicle battery pack. And now let's discuss about the electric vehicle packs forecast. Here is the, here you can see the 2021 to 2027 battery pack demand in gigawatt hour. Split by applications. So like split by applications. So we have split actually into four kind of automotive. Full electric vehicle, we call it BEV, then plug-in hybrid electric vehicles, then electric bus and electric truck. So from this slide, you can see that in 2021, the total battery pack demand in gigawatt hour was around 500 gigawatt hour. And by 2027, the battery pack demand will reach around 1300 gigawatt hour. The biggest market in all these four applications would be for BEV or full electric vehicle, followed by plug-in and then electric bus and electric trucks. Here you can see the battery pack market size in $1 billion from 2021 to 2027. We are using the same applications, BEV, plug-in hybrid, e-bus, electric buses and electric trucks. From this slide, we can see that in 2021, the total battery pack market for these four applications was around $50 billion. And by 2027, the market would reach around more than $150 billion. So it's like a big, we can see a big growth in this battery pack market size. Next is the battery pack market size split by pack components. So like in battery pack components, we have seen in the previous chapter that we have cells, BMS, thermal management system, safety components, housing, and electrical interconnection. So here you can see the total battery pack market split by these battery pack components. In 2021, you can see that battery pack market was around $50 billion, and by 2027, it will reach around $150 billion. Among all these battery pack components, cell represent actually the largest portion. It represents around 70% of the total battery pack market, followed by thermal management system and battery management system. So, okay, so now we are good with the technical trend of different components and battery packs, and we know the forecast or the market size of this battery pack. Now let's discuss about the battery pack supply chain. This is the lithium-ion battery, the complete supply chain, starting from raw material production to raw material refining. Then next step would be the manufacturing of various components of cells. Then there is battery cells, battery pack components manufacturer, battery module and pack manufacturer, and EV makers. And once this battery will reach up to the end of life, then these batteries can go for either second life applications or for recycling. So in this lithium-ion supply chain for battery pack for electric vehicle, we can see there are numerous players are involved, and then numerous players can find opportunity in this big lithium-ion battery supply chain for electric vehicles. In this slide, you can see the lithium-ion battery cell manufacturer, their geographical location. So from this slide, we can see that most of the cell manufacturers are located in Asia. In Asia also, especially in China, Japan, and Korea, followed by Europe. This is the lithium-ion battery supply chain, the cell production capacity. So as electric vehicle demand is growing, so obviously the cell demand will also grow. So to fulfill that, the high growth of this demand of cells for electric vehicle, many cell makers are increasing their production capacity, or they are establishing new factories in Europe. Europe mainly because most of the electrical vehicle manufacturers are in Europe, especially in Germany. So more and more cell makers are increasing their cell capacity in Europe. Based on the announcement, we can see that by 2020-30 in Europe, there would be more than 1,000 gigawatt-hour battery production. But it is just based on announcement. But sometimes we know that there is a difference between announcement and the reality. Here is, you can see the top battery manufacturer market share in 2021. So that top or the biggest battery manufacturer is CATL, which is a Chinese cell manufacturer company, followed by LG Energy Solution. It's a Korean company. And then again, BYD, Chinese company, Japanese Panasonic, and again, there is Korean Samsung SDI. So from this slide, we can say that all top battery manufacturers are also Asian companies. Yeah. Next is battery pack manufacturers, geographical location. So actually now battery pack manufacturers, they are mainly either concentrated in cell manufacturing, they are the cell manufacturing companies, or they also focused on the car makers. They are the car makers to stay closer to their potential customers. So most of the battery pack manufacturers would be in Asia as well as in Europe. Here is the battery pack supply chain. So now, like in traditional way, we see not only in battery pack for electric vehicle, but in any technology, we see that in traditional way, what happens is we have a long supply chain, and all the players of different part of supply chain, they only focus on their own product. And meaning that if we see that supply chain for battery packs, then battery cell manufacturers should focus on the cell manufacturing, battery modules should focus on only module manufacturing, car makers should focus on car manufacturing. This was the traditional way. But in this battery pack for electric vehicle, if you see now this supply chain is reshaping. Reshaping meaning that now if you see car makers are taking more and more interest in the different part of the supply chain, meaning that car makers are getting more and more vertically integrated. Like if you see now car makers, they make their own battery packs. They are also involved in designing of battery modules. And they are also taking interest in battery cell manufacturing, either by partnership with cell manufacturers. For example, like General Motors have partnership or have a joint venture with LG Energy Solution. And today there was a news that BMW, they have a partnership with CATL for their upcoming electric vehicle. So CATL will supply cylindrical cell for BMW. So car makers are taking more and more interest in battery cell manufacturing. Many car makers, they have in-house battery manufacturing factories like BYD, Daimler, they already have, and Volkswagen, they are also planning to make their in-house cells in coming years. At the same time, if you see battery cell makers, they are also involved in battery module manufacturing as well as battery pack manufacturing. This is the main battery management system players and their level of vertical integration. In battery management system supply chain, there is companies which make BMS ICs like Infineon and ST Microelectronics ROM. They make BMS ICs. If you see in the battery management system manufacturers, there are a few pure players in BMS. Pure players means there are few companies which make only battery management system. But then if you see upper side, then more and more battery module makers and battery pack makers, they also manufacture battery management system. And now if you see more and more tier 1 and car makers, they are also taking interest in battery management system manufacturing. Here is the thermal management system solution suppliers. So here we can see that thermal management solution suppliers we can find in all the areas like Asia, Europe, and America. Then safety component suppliers, they also we can find safety component suppliers everywhere. The Japanese PEC is it's like among the leading safety component supplier. In USA, if you see Littelfuse, it has a strong position in USA, and in Europe also there are many safety component suppliers, and like Mersen, Athon, Siba, these are the leading safety component manufacturers in Europe. Here is the battery pack housing suppliers. So different housing suppliers, they have different kind of housing materials. They use different materials like plastic, steel, composites and all. Most of the battery pack housing suppliers are located in Asia and Europe. Okay, now, so here is the conclusion. So now, as electric vehicle market is growing rapidly, much faster than we were expecting in the past. So as the electric vehicle market is growing, the battery pack demand will also grow, and it will continue to grow in the coming years. The total annual market we have seen in the previous slide, the total annual market in $1 billion for lithium-ion battery pack was actually in 2021 was around $50 billion, and by 2027, it will reach by $150 billion. In the supply chain, we have seen that right now car makers are taking more and more interest in battery cell and module and pack designing. To reduce the cost and to keep the flexibility of design, most of the car makers are actually, they are following a modular approach where they are cell to modules and module to pack approach. But now trend is moving towards cell to pack approach, as in cell to pack approach, more cells can be accommodated in the same size of battery pack. The most important component of any battery pack is battery cells. And if you see, if you talk about the cell manufacturing company, so the cell manufacturing company is dominated by leading players. Leading players meaning that the players which can combine strong manufacturing experience, which have technology know-how, and which have high volume manufacturing capacity. As of now, the battery cell supply is dominated by Asian players, especially in China, Japan, and South Korea. Actually, so now like in the battery pack, we see there are various type of components. So different car makers and battery pack manufacturers, they use different technology. Like they use different kind of battery pack components, different kind of cell chemistries, formats, use different safety components, cooling materials and all for the differentiation of their battery pack from their competitors. If you see in all components of battery pack, the biggest technology breakthrough could be made at the cell level, no? But you know that developing a new chemistry is not so easy, and it's lengthy. It's a lengthy process. It takes long time, many years to make a new chemistry, yeah? But other pack components like BTMS, thermal management system, they are also progressively improving. But in YOL, we don't see any major breakthrough in all these components of battery packs. The BMS actually, it's a crucial component of any battery pack, then and thermal management system. So in this BMS and thermal management system, these two components can enable the highest differentiated added value against the competitors. In this battery pack for electric vehicles, in the coming years, we will see more and more partnerships, more partnership between car makers and cell makers, or the different part of supply chain, and we will see more and more merger and acquisitions. Here is the report, is our upcoming report, is battery for automotive. In this report, actually, this 40 or 45 minutes of webcast is not enough to discuss about a battery pack for electric vehicle. But if you see this battery report, in this report, we have actually, you can see the deep information, or we have thoroughly investigated the various part of battery components. You can see the technology trend for all the components of battery pack. You can see the detail about supply chain and the market forecast for all the components of battery pack. In this report, we have included one dedicated chapter about 800 volt battery system, impact of this 800 volt battery system in the battery pack structure. And then again, we have one dedicated chapter about recycling and cycle life applications, impact of various kind of battery packs on these recycling and cycle life applications. And then we have another chapter about solid state battery and what type of battery pack would be there for solid state batteries. So thank you for your time, and I'm sure you will like reading this report.
Thank you very much, Shalu, for this very interesting presentation. So now it's time for the... And now I'm good
with question answer, yeah.
So thank you very much. And now it's time for the Q&A session, and we receive a lot of questions. So Shalu, let's start with the first question. What will be impact of 800 volt battery system on battery pack structures?
Okay. So this topic, actually, we have this chapter in our upcoming report. So actually now, like when we move from 400 volt to 800 volt system, it means like we are doubling the voltage, 400 volt to 800 volt. So we are doubling the voltage, meaning the charging speed would be faster, must be maybe double. But at the same time, we know no voltage is inversely proportional to the current. So in that case, when we increase or double the voltage range, and then in case the current would be half. And actually it's current which adds heat. So when we have a 800 volt battery system, in that case, the release heat would not be as much as in the 400 volt system. Although all the components of battery pack would be the same, but there may be some improvement in the various components of electric vehicle. For example, like as in 800 volt system, the current would be half. In that case, we don't need the same size or thick wires. In 800 volt system, we can use thinner wires, as the wires will take the flow low current. So you can use a thinner wire as well as you can use the smaller wire. So in that case, the component would be same, but there are little bit improvement or like a new kind of components must be included in 800 volt system.
Okay, thank you. Another question for you. What will be effect of cell to chassis trends on recycling? Question about recycling.
Okay, impact of, can you please repeat this question?
Yeah. What will be effect of cell to chassis trends on recycling?
Okay, got you. So now, like in one of the slides, we have seen that there is a modular approach to make battery packs for electric vehicle. Then we have a cell to pack approach, and the newest one is cell to sachet. So actually now, if you talk about modular approach, so in modular approach, there are two types of housing, pack housing and module housing. So actually it's easy to remove this battery pack from electric vehicle, but then after that there is two types of disassembly must be done before sending these cells in for the recycling. The disassembly of pack housing as well as disassembly of module housing. When we move from this modular approach to cell to pack approach, there would be only one kind of housing, the pack housing. It's easy to remove this the pack from electric vehicles because the pack is not directly attached with the electric vehicles. It can be removed easily. But then these cell to pack approach, they need to go for the one step of disassembly, the removal of this pack housing. But when we move towards cell to sachet approach, in that case, the cells will be directly attached to the vehicle sachet. So in that case, it would be quite difficult or quite complex to remove these attached cells from the vehicle sachet. So the removal of cells from vehicle would be much complex than this modular approach or cell to pack approach. But once these cells will be removed from the vehicle, that in that case, after that, there will be no disassembly steps. The cell can be directly sent for the recycling.
Thank you, Shalom. We have a question about the design. So for the battery pack itself, what is the most common design? Is it cylindric, as you show in the drawing?
Okay, actually, no, like we have various formats in this battery pack. We have three kind of formats. It's like cylindrical cell and pouch cells and prismatic cells. Right now, only Tesla is using cylindrical cell, and now BMW, like today there was a news that BMW is also going to use cylindrical cells in their upcoming electric vehicle, and for that they have partnership with CATL. So these two companies or car makers are using cylindrical cells in their electric vehicles. But then if you see Korean companies like Samsung SDI, LG Energy Solutions, they mainly use pouch-based format. And if you see the European players, like BMW, Daimlers, Audi, they mainly prefer prismatic cells. So it's overall, if you see that right now, prismatic cells are most commonly used format, but then depends on the like choice of cell makers and car makers. Different car makers and cell makers are choosing different kind of formats.
Okay, thank you, Shalom. Another question. For fast charging infrastructure, same thermal management system can be used?
Like for fast charging infrastructure, it means we are charging our battery pack much faster than normal charger. In that case, if you see, the cells will get hotter very quickly. So in that case, now we know that lithium-ion batteries are very sensitive towards temperature. So it's very important for them to keep. It's very important to keep them at optimum temperature range. For lithium-ion battery, optimum temperature range is around 20 degrees centigrade to 30-35 degrees centigrade. So right now we have no normal air cooling or liquid cooling to keep the temperature low of these cells. But if we will use fast charging infrastructure, in that case, the cell will become hotter very quickly. Same kind of thermal management system cannot be maybe used. We need to replace this conventionally used thermal management system to the other cooling system. For example, if you have maybe idea about the direct cooling or immersion solution. So in emerging solution, this technology is still in R&D label. So in emerging solution or direct cooling, the cells are directly submerged into this coolant. And in that case, as the cells will be directly touch the coolant, the cells will be, the temperature of the cells will cool down so quickly. In second way to reduce the temperature of cells would be move from 400 volt to 800 volt system.
Okay, very interesting. Thank you very much, Shalou. One last question, maybe if we have the time. What is the status of solid-state lithium-ion battery technology, and when do you expect commercial adoption in electric vehicles?
Okay. So you see that in solid-state battery right now, many companies, many startup companies are actually working on this solid-state battery chemistry. And they have mainly partnership with car makers, and together they are developing solid-state batteries. But if you see the today's status, most of the companies, like most of the solid-state battery are still in R&D label. Few companies, they say that they have started prototyping of solid-state batteries. But actually, if you see in real, we don't see that solid-state batteries commercialization or mass production. All the companies, their solid-state battery development are still in R&D label. Based on the announcement, like if you see Toyota and other companies, they have announced that they are going to use solid-state batteries after 2025. But if you see that today's development stage, we don't expect that the mass production of solid-state battery will start from 2025 based on the announcement. We are expecting that small production of solid-state battery may start from 2025, and these may be used in a few numbers of electric vehicles by 2025. But depends on the today's status. We expect that the mass production of solid-state battery would start maybe around 2030 or maybe later. And so yeah, this is we don't expect that solid state battery mass production is coming soon in coming years, in 3, 4, 5 years.
Okay, thank you, Shalou. Let's finish with the last question, maybe just for a few seconds. Do you have any idea about wireless battery management system?
Wireless battery management system, yes. So now, right now, like in this presentation, we have seen that battery management system, electric vehicle, the commonly used battery management system is like a master-slave topology. In this master-slave topology, that the slaves are, one slave is connected with various number of cells, and they are connected through wires. No, so in battery pack we have number of cells, so there will be number of wires, because that each the slave will be connected with number of cells, and then these slaves will be connected with the master unit. If we move from a wired BMS to wireless BMS, it means we can remove all these wires. No, so in that case, there will be, if we have a lot of wires, then no, there is more chances of failure, wire failures, breakage, and all. So if there will be this battery management system, wired battery management system can be replaced by wireless battery management system. In that case, these wires would be completely eliminated, which can reduce the weight of battery pack, which can also reduce the cost of battery pack, as there will be no extra cost of wires and cables. But then whenever we talk about no wireless system, like wireless charging or any wireless system, it has its own issue. Right now, General Motor, which have joint venture with LG Energy Solution and making Ultium battery packs, they announced that they are going to use wireless battery management system in their upcoming Ultium battery packs.
Thank you very much, Shalou. Thank you. The webcast is now ending. Thank you, Shalou, for your time and analysis. So
thank you so much, and thank you so much for your time.
Thank you. And please, let me remind you that you can find all our reports and monitors on our website, www.yolgroup.com. Do not forget to create your account on our new webcast, on our new website, to be informed on our latest news. And you will see a lot of things, and it's a new website, so please go to create your account. And to everyone, you will soon receive an email with the link to the recorded session within 24 hours. But please note that the presentation is already available, and it can be downloaded from the resource section of the platform on the bottom of your screen. Do not hesitate to contact us if you have additional questions. Thank you for all joining us today, and have a great day and take care.
Thank you.